Today's notes are Chapter 4, Day 2, and this right here is the focus. So five number summary, and the IQR mean, median, and range. In some of the worksheets that we've done, we've talked about symmetry. You haven't officially had this in your notes, so this may be a time where you need to pause the video and make sure you have this in your notes. Okay, so what you are focused on is, can you fold the graph in half? Okay, so if you drew a vertical line through the middle and would the edges match? If it does, then it's symmetric. And this will be one of the things that you talk about when you are describing the graph that you see. So more about this with symmetry. Usually the thinner ends of the graph are called the tails. So right here is a tail. And right here is a tail. Okay, so it's important to note where the skinnier end is. And we talk about whether or not graphs are skewed. Okay, it's skewed to the tail side. So in this figure, it's said to be skewed left. We would also say that it is negatively skewed because it's towards the negative side of the graph. So this is skewed left, and this is skewed right. This comes up a lot, so make sure we don't get that confused. It seems backwards, but it's where the tail is, okay? So the histogram on the right is said to be skewed right. So the other thing you'll talk about, so symmetry, you'll talk about what's happening with skewness, and you will talk about do any unusual figures stick out. So you're looking for any outliers or any gaps in the data, in the picture that you're looking at, okay? So there are lots of reasons why there are outliers, and you don't need to speculate too much. That can kind of be later on in your explanation, but you want to mention if there are any outliers. Are there any pieces of information that just doesn't seem to fit? Because it's either somebody filled something out wrong or that it truly is an outlier, and that's something that needs to be discussed as well. So does something stand away from the data? Okay. Are there any gaps in the distribution? Do we have more data from one group than another group, or why might there be gaps, or just are there gaps? So you're just describing any unusual things that stick out from the histogram that you're looking at. Okay, so the following histogram has outliers. There are 3 cities in the leftmost bar. Okay, so that would be something that you would mention. Okay, people in housing units. Well, okay, we notice that there are 3 cities that are farther away from everything else. This is all clustered together, and this is far off from that. Okay. Okay, so now we're going to talk about center. So is there a number that you would pick that describes, where most of the data is? Okay, so it's easy to find the center when it's unimodal or symmetric. It's directly in the middle. Not so easy to find it if it's skewed. So you're going to talk about that as well. So not if it's skewed or if it has more than one mode. So let's talk about median, because median is directly the center of the data. Okay, so if you remember median, or I want you to remember median from Algebra 2 or pre-calc, it's the value with exactly half the data values on one side or the other. So you put them in numerical order and you count 1, 2, 3, 4, 5, 6, 7. Okay, so from here to here, whoops, I missed. Here to here is the same number of pieces of data from here to here. So you include the outliers in that, okay? So it's the middle data value. It has the same unit, so make sure that you understand that as well. If you have an even number, you just count in the same from both. If you have an odd number, you take the middle 2, and it's the average of the middle ones. Okay. Okay, so how spread out is the distribution? So that's the other piece that you're going to talk about. You're talking about shape and center and distribution. Okay, so how varied is it? Are the values tightly clustered? What's the spread like? Okay, so you always report the measure of spread along with the measure of center, because that does make a difference. Are the numbers all smushed around each other, or are they spread out? Okay, they could numerically have the same median, right? The median could be the same, but we want to know how spread out it was. Okay, so we have to talk about the range. So the range is the maximum minus the minimum data value. Okay, so the range is affected by a single piece of data. So a single extreme value can make it very large and then not representative of the data overall. So can you think of some examples? One example could be engineering salaries, for example. Okay, there could be engineers who are really counted as CEOs and they make a lot of money. Whereas if we're looking at data, maybe we have most of the data here. Okay, but we have, so if the range, if we looked at this data, would be from here to here. But maybe once we include a data point out here or some data out here, now the range becomes here to here. So the range is affected by having a number out here. Okay, so the range here would be very different where if we included these. If we didn't include these, our range would be here. So that's something to keep in mind as well. Okay, it throws off the data. It's affected by that change. Okay, the next is the interquartile range. And the interquartile range, we call it the IQR. All right, we ignore the extreme values and we're only looking at what's in the middle. Okay, so first we're going to talk about quartiles because it's right in there, the interquartile range. So if you think of quartiles, what do you imagine the quartile could be? So quarters have to do with 25%. Okay, think of a quarter. It divides it into 4 equal sections. So the first quarter, or Q1, is the bottom-most 25% of the data. Okay. The Q3 is the topmost 25% of the data. And then in between that is what we call the IQR. Okay, so given a set of data, we have from here to here, say, we have 25% of the data. We have the median, which is going to be 50% of the data, because this is 25%. Okay. We have the third quartile, and there's 25% here, and there's 25% here. Okay, so the top quartile, number 3, the top being it's the top 25%, or you could say it's 75%, but usually they say it's the top 25%. Here would be quartile 1, the lower 25%. So Q1 and Q3, the difference between those is our interquartile range. And when we graph box plots in the next chapter, you will have to know exactly how to find the interquartile range. Okay, I think I just said that. So the 25th and the 75th percentiles, and the IQR is the middle. So it's 25% on either side of the median is where that is. Okay, the last piece of this is the 5-number summary. We're going to use our calculators to calculate a lot of this. You need to know how to do it by hand as well, but we will eventually be using the calculator. So make sure you have a calculator in class Thursday. Okay, I'm sorry, Friday. Make sure Friday you have a calculator in class. So the 5-number summary is all of these pieces of data, and there are 5 pieces of data, which is why it's the 5-number summary. So, and again, we're going to use this for the box plot, which again is next chapter. So we have the min and the max, the 2 quartile 3 and quartile 1, and the median. Okay, so from this piece of information, we can tell a lot about what the graph looks like. We can calculate the range. We can calculate these 2 quartiles, and we can calculate the median. We can calculate or look at how far spread out the data is. It doesn't tell us anything about modes, but it tells us the spread, and it tells us where the data is located. That's the importance of the 5-number summary. Okay, the last piece of information with this is the mean. You know it as the average, or probably of the mean as well. Okay, if we want to calculate the number, we average it, or we want to calculate if we have symmetric data other than the median, we will look at the average. Okay, this Greek symbol, if you had pre-calc, you know, you used it in series. It means to sum, okay, or to add. And it is a capital letter sigma, and it means to add together. So what this all means, and Y bar is how we say that, Y bar, okay, means that we take the total number of values, we add them together, and we divide it by n. And that's how we find the mean. So the mean is the average of all of them, totally different than the median. Okay, the mean feels like the center because it's the point where the histogram balances. Okay, but there are differences between the mean and the median. Okay, and here's the importance. Okay, the median considers only the order of the values. It is resistant to values that are really big or really small. It's resistant, meaning it doesn't change. Doesn't change, isn't affected. Okay, so that's what that means. The median is resistant. It doesn't change even if there are very big values. Okay, so when you're looking between the mean and the median, look at the data. If it's symmetric and you don't have any outliers, then use the mean. If it's skewed, you're going to have to use the median because those outliers are pulling the mean and will give you false information. Okay, and that is the last slide for this. So take a few minutes, write down what the summary is of this data, of the notes that you just took.